Hello people. Just a few things before starting the video. I want to make some corrections about last one. So first of all, harsh is not frost. I was trying to credit frost, but I don't know. I'm just stupid sometimes. Sorry for bringing that harshest brain name up. I'm sorry if it annoyed you. Sorry. It was frost who I was trying to credit. Sorry. Second of all, float pads, in case you don't know, these ones are not three power block rules blocks. They have a 525 50 power scale. I'm so sorry for that, and thanks Preston for telling me before I screwed up more than I already did. Yeah, just that. I'm sorry for all the errors, and yeah, straight into the video. Alright, welcome everyone to my wiring series tutorial series. Today we're going to be learning about transistors and conditionals and how to do binary memory with them. Sorry, I made a few errors in the last video, so for that I've corrected them now on the comments. So yeah, let's get straight on. So you might remember this design from last video. It's called the transistor or the latch. So basically, if the piston is activated, due to laser transmission, the signal won't transmit. And yeah, if there's no piston, it won't. Now this seems quite dumb and no one would use this, but trust me, we do. Um, so here we have a new circuit, introducing a new one. It's called the AND gate or the conditional. So basically, it will only turn on if both of the inputs are on. So if one is missing, the gate won't turn on. You can't really rush this one, by the way. I'll just circle around it so you guys can learn how to do it. Alright, yeah. So, um, these two are one of the essentials of computing in Prestonian wiring. So, um, I'm gonna now be teaching you how to do binary memory. So binary memory is being able to remember in ones and zeros. Because if you don't know, computers remember in ones and zeros. So, but what I mean by one and a zero, it's just or on or an off. So I made a little machine here. So if these transistors are on, it will be a one, let's say, and the the block that is assigned to when it's loaded will be activated because it's set to 1, and then the block will be activated. Yeah, so I'm just show you how it works. So if I click assign, I can make like a pattern. I'm gonna make like an L sort of shape. Okay, I stop assigning and I just load it, and my pattern will be saved in the machine until I change it. Sorry. So I can just remove it now, and nothing will load. Okay. Let's take a look at the machine, shall we? So here at this side we have basically simplificators. So basically I just take these signals and put them here, just to make it more easy for the user to see and not have lasers all scrambled around. Okay, so these two represent the assign and the load button. Okay, so here we have some beams, right? These are connected to each signal. So say that one this node over here is this node, which is connected to this one. Alright, everything great so far, but this over here, this little piston machine, is actually like a very big transistor. So basically I can turn it on and the flow will allow for all of these. So it will let the data flow to here and be saved. If it's not activated, the machine won't remember, but if the assign is activated, these pistons will go down and allow for the flow and allow for these to save. Okay, so once we stop assigning, if I hit the load button, this over here will activate and it will take the signal to here and it will activate all of these I'm stepping on. So basically if I have this one on and the load is fired, this one will activate this one, which will activate the block it's assigned to. I hope I made it clear. It's quite complex to explain machines, especially because it's quite a dirty one. This one, it's not really well organized. I tried my best, but I'm not too good at it. So yeah, if I hit assign, the huge transistor will go down, and if I now hit one bit of these, the flow will pass through it and in a storage transistor, which will store a 1 or a 0. This is currently set to a 1 or a true or whatever you want to call it. And if I stop assigning, which we don't have to by the way, load, I can see the piston flowing the signal to this one and then giving it to this block. Yeah. So one thing to keep in mind about this, in this game, pistons can't be saved while extended. So you can't save a piston in this state. So binary data has to be reset every time you save, and can only every time you save plot, by the way. So yeah, every time you wanna save the machine to your plot, make sure the pistons aren't activated and they're all in a neutral state. Okay, yeah, that's about it for today. I'm sorry this is a shorter tutorial. It was just two basic concepts. About the AND gate or the conditional one. Why am I introducing this to you today? It's because you can sort of like filter the data. So let's say I want to have some if statements here, like if these two are on, I can make a certain type of output or whatever. Or if this one is on and this one is off, you can do that by reversing. Well, do certain things, and you can make like complex data reading, so you can actually read data in a complex way, and make a sort of Turing machine. You can search that up in Google. This is the name. Okay, yeah, that's it for today. Thanks for watching, and sorry for the errors in the last video. Thanks, Preston, for correcting me. Yeah, have a nice day.